Good day, viewers. Welcome to another mathematics lesson. My name is Khaled Diallo, and in today's lesson, we are going to look at trigonometric ratios. And the ratios that we have are sine, cosine, and tangent. This lesson is for those in grade 9 or above, and above rather. You can make the best use of this lesson, as we are going to talk about trigonometric ratios. We're going to find out how do we use these trigonometric ratios and under what circumstances can we use them, and if you have a situation wherein it is a trigonometric ratio, which one of them are we going to use, that is whether it be in sine, cosine, or tangent. So we look at the ratios itself, because there are some we call sine in short. We have another one that we call cos, and we have another one that we call tan for short. So which one of them do you call sine, which one of them do you call cos, and which one of them do you call tan? Looking at the first one, we have sine. In short, we call it as sine, S-I-N, in short. And then the other one we have cos, and the one that we call cos is cosine. Cosine is the one that we call cos in short. Now cosine is called cot for short. And then the third one, which is the tangent, is called tan. So we'll be using sine, cos, and tan in the place of sine, cosine, and tangent respectively. So whenever we say cos, whenever we say sine, we are referring to the sine, okay? And when we say cos, we are referring to cosine. And whenever we say tan, we are referring to the tangent. Those are the fundamental trigonometric ratios: the sine, the cosine, and the tangent, which we are going to use as sine, cos, and tan. We move on. The name of the angles, the name of the angle follows the trigonometric function. If the angle is named alpha, the function values become sine alpha, cos alpha, and tan alpha. That is, if we have the diagram and our reference angle is alpha, that is this symbol here, is called alpha. If the reference angle is alpha, then the trigonometric function we read, if you are dealing with sine, is going to be sine alpha. If you are dealing with cos, it's going to be cos alpha. And if you are dealing with tan, it's going to give us tan alpha. Where if you have a right angle triangle, if you add alpha and beta, it's going to give you 90 degrees. Again, if the angle named beta is the function values become, if the angle is named beta, the function values become sine beta, cos beta, and tan beta. How about if the angle is named, for instance, A? If you have a triangle and that's 90 degrees, here we have A and there we have B, and our reference angle is angle A. We are concentrating on angle A as our reference angle. So in this case now, the function, the trigonometric function will be sine A, cos A, and tan A. So if, for instance, in this case, A plus B is going to give us 90 degrees. And again, if for instance we are given an angle, if for instance we are given a triangle, and here is 90, and we are told that this angle is, for instance, A, and this other angle is 30 degrees, and our reference angle is the angle that is 30 degrees. So the trig functions will now be sine 30, or we have cos 30 if you are dealing with cos, and it is going to be tan 30 if you are dealing with the tangent. So those are the various ways that we can have our angle. Like here, when it is alpha, it's going to be sine alpha, cos alpha, and tan alpha. And when it is beta, it's going to be sine beta, cos beta, or tan beta. So again, whenever we have the angle, being it a specific variable given to us or a number, is going to be, and it is the reference angle, is going to be sine of that number, cos of that number, or tan of that number. So we move on to the trigonometric ratios itself. Like for instance, when we have a right angle triangle and our angle here is theta, remember we have three sides in the triangle. The longest side we call the hypotenuse. The opposite of the angle theta, we call it the opposite side. And the side adjacent to angle theta, we call it the adjacent side. Now these three terms are very important in today's lesson. Remember, we have a triangle and our reference angle is angle theta. Our reference angle is angle theta. So the side that is opposite to that angle, the side that is opposite to angle theta is called the opposite side. And the side that is adjacent, this side that is adjacent to angle theta, is referred to as the adjacent side. And the other side, that is the longest side there, is called the hypotenuse. So that will give us the formula. Sine theta, if you are looking for the sine of this angle, sine theta is equal to opposite side divided by the hypotenuse. That is opposite divide hypotenuse. That is the formula for sine. Now, if for instance we are using cos now cos of the angle theta is equal to the adjacent of that angle divided by the hypotenuse. So cos is going to give us adjacent divided by the hypotenuse. And finally, when we are dealing with tan, now tan of the angle theta is equal to the opposite of the angle divided by the adjacent of the angle. So tan is going to give us opposite divided by the adjacent. So sine is opposite divided hypotenuse, cos is adjacent divided by the hypotenuse, and tan is the opposite divided by the adjacent. So we are going to use that to solve some problems. That is, when we are giving some sides and an angle, how do we find the cost of that angle, and so on and so forth. So we are going to talk more on that in the lesson. Like here, these trig ratios are used so often that they are memorized by the expression SOHCAHTOA. Now SOHCAHTOA, the term, the expression SOHCAHTOA here will help us to remember the formula. Like so here is SOH. Now the S will stand for the sine, S will stand for sine, O here will stand for opposite, O here will stand for the opposite, and H here will stand for the hypotenuse. So the so there will give us sine is equal to opposite divide the hypotenuse. That is a simple way to remember it. Then K, which is CAH, C there will stand for the cos of the angle. Then A here will stand for the adjacent side of the angle, and H there will stand for the hypotenuse of that angle in the triangle. So that will give us the formula for the cost. Then we move to TOA, that is TOA. The TOA there, T there stands for the tan, that is the tangent of the angle. O there stands for the opposite, and A stands for the adjacent. So you can see that when you memorize SOHCAHTOA, it will simply give you the formula for the sine, the cos, and the tangent. For the sine, it is equal to the opposite divided the hypotenuse. The cos of the angle is equal to the adjacent divided the hypotenuse, and the tan of the angle is the opposite divided the adjacent. So that's how we are going to use sine, cos, and tan based on the SOHCAHTOA. We look at our first question. It says, what is the value of sine theta? What is the value of sine theta? Now, we're looking at the diagram. We are given a right angle triangle, and then we are given an angle here. This angle is angle theta. It is our reference angle. Now, the side that is opposite to this angle is where we have the length of 7.5. 7.5. Now, here is going to be the opposite of the angle. That is our reference angle. And the side that is adjacent to our reference angle is the side that measures 4. That is the adjacent. That is the adjacent side. And here is going to give us the hypotenuse. There we have the hypotenuse. So now what we are asked to find, what is the value of sine theta? We want to know what is the value of sine theta. Now remember, in sine, using the SOHCAHTOA, CAH and TOA. SOHCAHTOA here, we have sine will be so. Now, if it is the sine now, it means we are dealing with the opposite and the hypotenuse. We are dealing with the opposite and the hypotenuse. So sine of the angle theta is equal to the opposite divided by the hypotenuse. So that is going to give us sine theta is equals to the opposite divided by the hypotenuse. Then sine theta is equals to, what is the opposite? What is the opposite there? The opposite is 7.5. So we are going to have 7.5 divided by, and what is the hypotenuse? The hypotenuse is 8.5. That is going to give us 7.5 divided by 8.5. So remember, we are given some options, and the options are 17 over 8, 8 over 17, 15 over 17, and then 15 over 4. So let's try to simplify this and see what we will have. Now, since they are decimals, when you multiply and they have only one decimal place, when you multiply the numerator by 10 and the denominator by 10, this is going to give us 75 divided by 85. And then 5 into 75 is going to give us 15 divided by 5 into 85 is going to give us 17. So it means our answer, that is sine theta, sine of the angle theta is equal to 15 divided 17. So let's look at the options. Option A, we have 17 divided 8. Option B, we have 8 divided 17. Option C, we have 15 divided 17. And option D, we have 15 divided 4. So the correct option here is going to give us option C, which is 15 divided by 17. When we calculated sine theta, we got 15 divided by 17. From there, we look at another question. Here we are asked, what is the value of tan? What is the value of tan? Again, we are given a reference angle. We are given a reference angle, that is tan A. We are given a reference angle. We are given a reference angle which is angle A. Now, what we are asked to find is the value of tan A. So again, at the beginning of the lesson, we've talked about an acronym that gives us the formula of sine, cosine, and tan. Remember, it is SOHCAHTOA. Now, for tan, it will be TOA. TOA. TOA here, the T will stand for the tan of the angle A. O here will stand for the opposite, and A there will start for the adjacent. So in short, we can have it as tan of the angle, that is tan A, is equals to the opposite divided by the adjacent. The opposite divided by the adjacent. Now let's look at the figure again. Remember, it is a right angled triangle, and then we have our reference angle as tan A, as A rather. So the side that faces the angle A is the opposite. The side that faces angle A is the opposite. So the side that is adjacent to angle A, it will be the adjacent. And then the longer side there is referred to as the hypotenuse. I understand that. But then in this case, we are asked to find the value of tan A. And in finding the value of tan A, we need the opposite and the adjacent. So the opposite we know is 7, and the adjacent. So in this case, remember we are dealing with tan, and tan A is equals to the opposite divide the adjacent. And the value of the opposite from the diagram, we have the opposite is equal to 7, and the adjacent is equals to 24. So now tan of angle A, that's tan A is equal to, what is the opposite? The opposite is equal to 7 divided by the adjacent, which is equal to 24. So there we have tan of angle A is equal to 7 all over 24. Now remember, we are given some options. Let's look at the options and see what is going to be the answer for tan A. The first option that we have, it says 24 over 25. The second option is 7 over 24. The third option is 7 all over 25. And the fourth option is 24 all over 7. And our answer here is 7 all over 24. 7 all over 24 will give us option B to be our correct answer. I hope we understand that. Then we move on to the next one. Here it says, given that tan A is equal to 3 over 4, can you find the ratio of sine A? Given that tan A is equal to 3 over 4, can we find the ratio of sine A? Now let's confirm if tan A is equal to 3 over 4. Remember, tan is TOA. TOA. Now tan A is equal to 3. Now here it will mean that the opposite is equal to 3 and the adjacent is equal to 4. That is what this statement is telling us. Now if our reference angle is here, angle A, the opposite is what? The opposite is equal to 3 and the adjacent of the reference angle is equal to 4. That means the given information is correct. Now what are we asked to find? We are asked to find what is going to be sine A. Well, we are given options just like the other ones. The first option, letter A, says the sine A is equal to 4 divided 5, 4 over 5. B says 4 over 3. C, we have 3 over 5. And D, we have 5 all over 4. So we are going to do the calculation. Remember, we are asked to find sine now. And from SOHCAHTOA, we have SOH as so. Now this is going to give us sine of the angle A is equal to the opposite divided by the hypotenuse. Sine of angle A is equal to the opposite divided by the hypotenuse. Now let's go back and see. Our reference angle is angle A. Now the angle that is opposite to angle A, the side that is opposite to angle A will be our opposite. And the side that is adjacent to angle A will be the adjacent. And the other side now will be the hypotenuse. Now we are looking for the sine of angle A. Sine of angle A is equal to the opposite divided by the hypotenuse. So this is going to give us, the opposite is what? The opposite of the reference angle is 3. We have 3 all over. Then the hypotenuse is 5. We have 3 all over 5. So in short, we are going to have sine of angle A is equals to 3 all over 5. Sine of angle A is equal to 3 all over 5. Now let's look at the options and see which one is correct there. The first one says 4 over 5. The second one we have 4 all over 3. The third one we have 3 over 5. And the fourth one is 5 all over 4. Well, our answer is 3 over 5. Therefore, it means option C is our correct answer in this question. Then we move on to another question. Okay, here it says, given that tan beta is equal to 3 over 4, can you find the ratio of cos beta? Now here our reference angle is beta. Our reference angle is beta. We are told that tan beta is equal to 3 all over 4. Now if tan beta is equal to 3 over 4, it means the opposite is equal to 3 and the adjacent is equal to 4, because tan of beta is equal to the opposite divided by the adjacent. Tan of beta is equal to the opposite divided by the adjacent. So if tan beta is equal to 3 over 4, it means the opposite of our reference angle beta is equal to what? 3, and the adjacent is equal to 4, as we have it on the diagram. But what are we asked to find? We are asked to find the ratio of cos beta. The ratio of cos beta. And the options that are given to us are 4 over 5, 4 over 3, 3 over 5, and 5 all over 4. So we are going to, again, use SOHCAHTOA to help us trace the formula that we use for cos. Then we calculate and see what is going to be our answer. Again, using SOHCAHTOA, we have SOH CAH and TOA. Now, CAH there is the one that we need, which is car, because we are asked to find the cost of the angle beta. So this is going to give us cos beta is equal to adjacent divide the hypotenuse. Cos beta is equal to the adjacent divide the hypotenuse. Again, the adjacent of what? The adjacent of angle beta. So 3 here is the opposite of the angle. 4 here is adjacent of the angle. And 5 here is the hypotenuse of the triangle. So what we are interested in is to find what is cos beta. And we know that cos beta is equal to adjacent all over the hypotenuse. Now this is going to give us, what is the adjacent? The adjacent, the side adjacent to angle beta is what? Is 4. So we are going to have 4 all that over the hypotenuse. The hypotenuse in the triangle is what? Is 5. So we are going to have 4 all over 5. So in short, we have the cost of angle beta is equal to 4 all over 5. So again, we go back to the options and then confirm. Option A, we have 4 over 5. Option B, we have 4 over 3. Option C, we have 3 all over 5. And option D, we have 5 all over 4. Well, the correct option here is going to be the option that has 4 all over 5. That is cos beta is equal to 4 all over 5, which is going to give us the first option as the correct answer in this question. Then we look at another one. Question 5, it says find sine theta to the nearest 100. Find sine theta to the nearest 100. What are we asked to find? We are asked to find sine of the angle theta. Now here our reference angle is this angle, theta. Now the reference angle faces the side that measures 8.0. So that side will be the opposite. Always it is the reference angle that dictates the opposite. The reference angle is facing this side, so it is the opposite. Now the side that is adjacent to the reference angle now is going to be referred to as the adjacent. That is the side that measures 3.0. And then the other side, that is the longest side there, is going to be the hypotenuse, which measures 8.5. So what are we asked to find? We are asked to find the sine theta. The options that are given to us, we have A is 0.84, B we have 0.89, C we have 0.92, and D we have 0.94. So we are going to calculate and see which option there is correct. Remember, we are asked to find sine. And remember, we also said sine of the angle theta is equal to what? We said it's equal to the opposite divide the hypotenuse. Sine of angle theta is equal to the opposite divide the hypotenuse using the acronym SOHCAHTOA. SOH, CAH, and TOA. So here we are dealing with sine, so we are going to use the first one, which is SOH. That is, sine of the angle is equal to the opposite divided the hypotenuse. Again, we are looking for sine of angle theta. Now sine theta is equal to, what is the opposite here? The opposite is 8.0. The opposite is 8.0. We are going to have 8.0 divided by, and then opposite divide the hypotenuse, and the hypotenuse is what? 8.5. The hypotenuse is 8.5. So there we are going to have divided by 8.5. Good. We have 8.5. So therefore, what we have now is sine of the angle theta is equal to 8.0 divided by 8.5. 8.0 divided by 8.5 is going to give us 0.9411. But then we are told that in the question that our answer should be in the nearest hundreds. Means we should have 2 digits after the decimal point. So our answer is going to be sine of angle theta sine theta is equal to, now if you are to approximate it to the nearest 100, it's going to give us 0.94. So the correct answer there, that is sine of angle theta in this question, is going to be 0.94. So we look at the options. The first option we have 0.84, the second option we have 0.89, the third option we have 0.92, and the fourth option we have 0.94, and in our answer we have 0.94. So therefore the correct option is going to be option D, which gives us the answer as 0.94. And that brings us to the end of the lesson. You will have your homework, and then you will see exercise 4.1 and 4.2 of the geometry worksheet to do your homework. On that note, I thank you all for your attention.